Alright, we're going to try this next one. Again, identify your key pieces. You need your A, you need B, you need to find your period, and then to make labeling easier, do your period divided by 4. Okay, A is going to be 1, B is 4, the period then is 2 pi over B, which is 4, or pi halves. Count out 1, 2, 3, 4, and your period always goes there. Then we're going to figure out what the rest of the marks are by taking the period and dividing it by 4, which is always basically multiplying by 1/4. So this would be pi over 8. Okay, 1 pi over 8, 2 pi over 8, which reduces 3 pi over 8, and then the 4 pi over 8. 2. 4 over 8, which is pi over 2. Blah, blah. Okay. So now we've also got to do the amplitude. Now, amplitude is 1, so we just got to go up 1 and then down -1. Okay, it is sine, so now that we're all labeled, we can start to graph. Right now, though, I want you to pay attention to the fact that there's this guy. So my midline oopsie. My midline, midline. Oh, I'm gonna scream at you. I mean, really, like, you have to do stupid stuff always to me. D-L-E line. Which means that after I draw it, there's actually supposed to be a dashed line here at -1. But just to kind of keep it a little bit simpler, I usually do my original sine graph. So the sine of 4x starts with an intercept, ends with an intercept, intercept in between, and then a maximum and a minimum at the other spots. Now, since I know that my midline is actually right here now, now you're going to look at the pieces and say, okay, look, this is where my start was at 0, 1. The midline was at y equals 0. Now it's y equals -1. So this point needs to move down 1 to get on the new midline. It starts and ends at the same spot, so pi halves is also going to go there. And then pi eighths is also going to go there. Okay. One thing that I've had students do in the past, and this makes complete sense to me, is we start getting a big mess there in between. So sometimes we'll go down here to the bottom and label it here, your x-axis, so that's a little bit easier than trying to squeeze everything in and still make it pretty. Okay, anyways, so we've got our points labeled. Now the orange one was the original, and it had these points on it. But now our midline, again, is at y equals -1. So the midline, if this was the intercept on the original midline, it is moved down 1. It's still the point on the midline. It starts, ends, and in the middle, all have the same line and they go on the midline. But basically, all I did was move that point down 1. So this point's also going to come down 1. And then this point's also going to come down 1. And we can, from there, connect the dots and make a nice pretty line. So here we go. Here's my sine. Up, through the x-axis, down, and back up to there. Woo, that was rough. Try that one a little bit better. Yeah, that was so much better. Whatever. Okay, so that's the basic sine. Now the midline, all that really meant is that the points move a little bit. They might move down, or maybe the midline's higher, then they're actually going to move up. Okay, so here's the basics behind graphing these. Okay, basic forms, y equals a sine of bx plus d, and the same with cosine. Amplitude is still the absolute value of a. It is always a positive value. But this is the new stuff. When a is negative, you reflect, which means the max becomes the min becomes any maxes, basically you're flipping them, but the intercepts do not change. They only change when you move that midline. Okay, and then period 2 pi over b, and the midline is at y equals d. So let's identify what we can. Looking at our graph, here it is over here. We've got an amplitude of 2. Looks like there's no b in there, but technically that's 1, which means the period is 2 pi over 1, or 2 pi. And then to count, we're going to go period over 4, which is 2 pi divided by 4, which is pi halves. Okay, let's count out. 1, 2, 3, 4. That's pi halves. Or sorry, 2 pi. We're counting by pi halves. So pi halves, pi, 3 pi halves. I'll let you go and figure out the pieces beyond that. Okay, amplitude. There's 1, there's 2, there's -1, -2. Okay, this graph, we've got our A, B, and then we've also got D that we've got to figure out what that does. So this guy right here, that's your new midline at y equals 1. And we'll put that in a second. So key features here. For a sine graph, we're doing sine. So the basic beginning of it is that it starts on the x-axis at an intercept and ends at an intercept, and then there's an intercept in between. And then between the start and the middle, there's a maximum, start in the middle, there's a minimum. And that would be your basic sine function, right? If I connected the dots, that would be this beginning part right here, the 2 sine of x. But we've got 2 changes that need to be made. One of them is this guy right here. That's a reflection. And then this other one is right here with that whole idea of the midlines moving. So I'm not going to connect the orange dots because it starts becoming this big, huge picture and mess. So I'm just putting the dots on there because what I need to know now is, okay, here's my actual midline at 1. Whoops, I went the wrong way, didn't I? Okay, so our midline is actually up here at y equals 1. So then I ask myself, okay, oh wait, I forgot to reflect. Oopsie. Oopsie. Always do that vertical shift, the midline last. It's much easier. Okay, anyways, back to the reflection. Every intercept stays the same, and then the max becomes a min, and the minimum becomes a max. But the intercepts stay the exact same. So if this was our final graph, which it's not because we have one more change to make, then it would look like this. Get off the board. This would be the reflected part, right? So that's with this reflection guy. But we also have to take care of this midline right here. Okay, midline now it says is at y equals 1. Okay, I'm going to draw a line for y equals 1. And then it's just a matter of moving your points. Okay, this is usually the midline. Now it's up here at 1, so my intercept here is actually going to go up here. And then there's also one at the end and one in the middle. So we've got 3 of our 5 key points already plotted there. Now, I'm on the blue one, I'm reflected at this point. So this piece right here, this point, he's also going to move up 1. This one right here, the blue guy, he was the maximum. He goes up 1 more, and there's your 5 key points. So the red's the final answer. The blue is just 1 step in between to get that reflection taken care of. Doing it all at once gets really hard. So any kind of amplitude or period shift or period change, do those first. Then if there's a reflection, reflect after that. And then the last one you should do is change the midline and move all the points. Okay.